Well, happy Thursday, 5th grade. As I promised, here's a double lesson. Remember, never on a whim. Nothing I do in education is on a whim. What I do is these two lessons fit really well together, so we're just going to bust them out. L107/108. We're going to be both finding common denominators and using them. However, we've been dealing with these ideas already, so I just want to kind of do a bunch of examples, and hopefully we come out on the right end. Here's the thing. Common denominators, we can always talk about common denominators. We're really always most focused on the least common denominators. Now, you're probably like, well, I know about LCM. Are we talking about the same thing? Yeah, theoretically, kind of. LCM stands for the least common multiple, and we utilize LCM to determine LCD, the D standing for that denominator, right? So, for example, if we were to look at this situation, 5/8, 3/4, magic circle, where we know they want us to compare either equal, greater than, or less than, what we can do is make sure that the denominators are common. They currently aren't. So we can take some time to think about the LCM of 4 and 8, and hopefully you wouldn't even need to list those out because we would know that it's 8. So the LCM is clearly 8, therefore the LCD is 8. So this 5/8 already has a denominator of 8. I'd have to think about the 3/4, and we've seen before, so if I need 3/4 to have a denominator of 8, what would I multiply by? And remember, it has to be a fractional form equal to 1. Well, we know that 4 times 2 is equal to 8, therefore I have to do that. 3 times 2 is equal to 8, and I end up with 6/8, yeah? So now when I go to compare, I just think of cake. 5/8 compared to 6/8, and if I like cake, no question that 5/8 is less than 6/8. Therefore, the original, which I have to answer the original, 5/8 is less than 3/4. Let's press on. Now, more importantly is this situation, and so we're going to write a statement down here. Whenever I add or subtract fractions, and again, this is a nice Pavlovian response for us. We've been doing this for a long time. Let's go ahead as a class and take it through all the way, filling out both blanks. I want to hear you all the way out in Sherman Oaks. Let's scream it out. We're coming near the end of our book, near the end of the school year. I want to hear you. Let's do it on the count of 3. 1, 2, 3. Whenever I add or subtract fractions, I must ask myself, are the denominators common? Oh, I am so proud of you, 5th grade. You are right. The denominators common, meaning are they the same? We've been Pavlovian training you to always ask yourself that. We look at the 8, we look at the 6, and we say, no, they are not the same. So what do we got to do? Well, we have to find our LCD, which is thinking about our LCM of 6 and 8. Now, again, maybe you already know it, and that's fine. I am not requiring you to make these lists. However, if you don't know it, work on your number sense over the summer. I promise you can. Learn all your basic facts and know them like the back of your hand, because I know it. But if I had to list it, I would say, well, the multiples of 6 are 6, 12, 18, 24. At that point, I should go, okay, well, I know that it's 8, 16, 24. Therefore, 24 is my LCM. But as we know, the LCM translates into the LCD. So I have to take this 1/8 and I have to reform it, not changing its value. So I'm going to multiply it by a fractional form equal to 1. And I need it to have a denominator of 24. Well, clearly 8 times 3 is 24. Therefore, I'll do 1 times 3, 3/24. And I'll rewrite that 1/8 as 3/24. Now I have to do the 5/6. So 5/6 times what fractional form of equal to 1? So wouldn't that be, well, it's going to be 4/4, right? So therefore 5 times 4 is 20/24. Now, am I requiring you to do the little kindergarten button? No. At this point, you should be highly developing your number sense and immediately almost be able to tell me that 1/8 is equal to 3/24 and that 5/6 is equal to 20/24. Now when I go to add these, I notice that the denominators are common, so all I got to worry about is that numerator. So I'll say, okay, 20 plus 3 is 23, and I keep the same denominator, and I say 24. Boom! There is more. Same with subtraction. The statement is whenever I add or subtract fractions, I must ask myself whether the denominators are common. Are they? Well, no, because that's a 4 and that's a 6. That's not common. Should I have to list out multiples? No, that's kind of like, do you need to? Do you personally need to, can you tell me the LCM right now? If so, we'll go with it. But if you had to list them out, list them out. You should probably pause us though, because we're going to dive in. So clearly the LCM of 4 and 6 is 12. So therefore the LCD will be 12. And I'll set this up. And then I just kind of think, okay, so I'm going to work on this 3/4. 4 times 1 equals 12. 4 times 3 is 12. So 3 times 3, 9/12. 3/4 is 9/12. Same with the 1/6. So I know that 1/6, 6 times 2 is 12. Therefore, 1 times 2, 2/12. 1/6 is 2/12. Now that the denominators are common, all I got to worry about those numerators. 9 minus 2 is 7. Therefore, 9/12 minus 2/12 is 7/12. And I can box that up. Nice. We're doing great. There's more. Let's get back to comparing a little bit, okay? So I see this situation. I can, they don't have common denominators. Let's make them common. I want to focus in on that 3 and 5. And again, if it's not immediately apparent to you, you should be making out lists. But if you already know, let's do it. But if you don't know, please pause. Make the list and come back when you know, because I know that many of us already know that the LCM or LCD would have to be 15. So that'll be a 15, and this will be a 15. Then I just do my little thinking. 3 times what equals 15? So that's a 5. So 2 times 5 is 10. All right. Then 3/5, 5 times 3, 9/15, right? And then I can compare. Well, if I'm thinking about cake and I like cake, 10/15 is definitely greater than 9/15. And then I have to make the statement in the original that 2/3 is greater than 3/5. They're pretty close to each other. They're about 6 2/3% away from each other. Yeah. Right. Oh, here we go again. Subtraction. Whenever I add or subtract fractions, I must ask myself if the denominators are common. I look, 10 and 3, they are not. What is their LCM, LCD? Well, wouldn't it be 30? So I'm just going to do it right now. So 10 times 3 is 30, therefore that'll be 7/10 is 21/30. I'm going to subtract. All right, let's do it with the 3. So we know 3 times 10, so that'll be 20/30. Oh, well, those are kind of close. Yeah. So 21/30 minus 20/30, yep, you got it, 1/30. So think about it, like the difference between those two numbers is pretty small. It's 1/30. We know 7/10 is a percent is 70%. 2/3 is 66 2/3%. So we're really only talking about 3 1/3% difference. They're pretty close, those numbers. That's why their difference is so small. 1/30 represents 3 1/3%. Boom. Hey, more, Moss. We love it. Let's do it. 1/3, 1/6. Are the denominators common? No, they're not. What is their LCD? It would have to be 6. So I have to change that 1/3. And again, you should be moving towards the place of practicing this enough that you know immediately that it's 2/6. Then you're going to add that 1/6. Then we know that that's going to be 3/6, but don't you dare box that up, because you know that our fractions are expected to be reduced. They've been so pretty much our whole year. So we think about GCF and end up at 1/2, and we get to box that up. Now, one last kind of idea we have to get to. It's something called cross products. Now, personally, I don't use cross products in this situation. I believe you forming new fractions that have shared denominators is your best bet. However, your book talks about it. Sometimes it asks you to do it. And cross products, in this case, are used for comparing, right? So not for adding or subtracting as we've been doing. I do not prefer this method. I want to use cross products when we do proportion, right? Right? But for this, the way you could do it. So let's say I took 3/12 and I wanted to compare it to 1/4. Now, the reason why I didn't like this as a child is I always forgot, which way should the arrows go? So we're going to write down, just if you're ever going to use this method. We start at the bottom and we always go to the top. We start down and go up, right? Start down, go up. And basically cross products implies multiplication. So that means I start at the bottom at 12, I go up to the 1, so we always go down to up. Remember that. And that might help if you want to use this. So 12 times 1. That ends up on the right side there, 12 times 1, because I went from the bottom left to the top right. That's on my right side. That's important. On the other side, I have 4 going up. I'm multiplying it by 3, so that's 4 times 3. It ends up on the left side. Now, clearly, 4 times 3 is 12, and 12 times 1 is 12. So what can we say about 3/12 and 1/4? Well, yeah, they're equal. Maybe you already knew that, yeah? You were like, why would I use cross products? I don't No, really. I don't. I mean, maybe I would use it more for something like this. These guys are kind of close. 5, 6, and 7, 8. Who knows? Maybe they're even equal. We could share a denominator, and we will. But right now, let's just cross product. Remember, down to up. Down to up. So that's my 6 times 7. Down to up. That's my 8 times 5. Then I know that 8 times 5 is 40. 6 times 7 is 42. 40 is less than 42, therefore 5, 6 is less than 7, 8. And those are pretty darn close, too, when it comes down to it. 5, 6 is 83.33%, and 7, 8 is, don't tell me, 82.5%. Very, very close. But clearly, well, no, that must be wrong. 87.5%. Oh, my brain. Where is my brain? Okay. There must be more here. Hey, let's do it the other way, because I really do want you to understand that the other way is mas. 5, 6. Well, what's the LCD? The LCD would be 24 of 6 and 8, right? So 6 times 4, so that would be 20 24ths. 7 eighths. Okay, well, I know I'm going to multiply that 8 by 3 to get to 24. 7 times 3 is 21. Boom. Same, right? And I got to tell you, and you don't have to write this part, but this is far more preferable. It just is. It's going to help you with a lot of other math. Doing cross products, I don't know. I mean, if your book tells you to do it, you got to do it. What am I going to do? Fortunately, you'll likely never be assessed on it, except for in your homework. And we can say it was a double lesson. Woohoo! Love these. So you are expected on this Thursday to do the split. You're going to do 107, 108. Now, I know we don't normally do that, but I'm telling you, evens for 108 and odds for 107. And that's just how this homework's going to go. And we will check this tomorrow, like normal. And guess what? Got another double lesson tomorrow. You might go, what will that mean for homework? I will lead you and guide you through Google Classroom. I hope you're well. You can reach out to me anytime. Bye.